Now that we know how to solve exponential and logarithmic equations by hand, in your homework, you're also going to have to solve by graphing. And graphing is a good and useful tool for some of the equations we are actually solving by hand. So example 3 says graph f of x equals 2 to the x and g of x equals 3 on the same plane and shade the regions bounded by the y-axis and then solve f of x equals g of x. Use the window display of this by this. So first, if I solved this by hand, this would not be very hard, right? When I have f of x equals g of x here, okay, my f of x is 2 to the x, my g of x equals 3. So this is my equation. Now, if I'm solving for x, I have no way of solving for x since it's in that exponent position, so we would rewrite it. And so when I rewrite, we would go base and base of your exponential to the other side of the equals. So this is log base 2 of 3, and that equals your exponent. So this is my answer. Now, if I put that into my calculator, we would get, and I'll show you how to do it in both of these calculators. If you have the 84, you can just hit alpha window and go down to number 5, log base. So we have log base 2 of 3. So if I round this, this is roughly 1 point, we'll call this 585. Okay, and just a little side note again, this is my exact answer. This is my approximation or rounded answer. It is not exact, it's very close, but it's not exact because we're losing a lot of decimal right there. Okay. If you have the 30 or even an 83 for that matter, you have to use the, what is it called? The change of base formula. So we would have to do log 3 divided by log 2. And we get the same answer there. Okay. Now, that's how we would solve this one by hand. Now, if we wanted to solve this one by graphing, I'm going to pull up DESMOS here, or I already have it pulled up. When I put this into DESMOS, in my line 1, I'm going to put y equals the right side. And then in the second line, I'm going to put y equals 3. Okay, so to be able to solve these using a graphing utility, whether it's graphing calculator or DESMOS, you're doing y equals the left side and y equals the right side. And what we are looking for is the intersection right here. So my answer is where these two graphs cross. Okay, now to get this exact thing on DESMOS or on your graphing calculator, you need to use these windows here. So this first one is talking about your X. The second one is talking about your Y. So let's type this in. I'm going to do Y equals 2 to the X. And then Y equals 3. Now again, if I want this to match exactly, we're going to use this window here. So they want us to go from -5 to 5 with a step of 1. And then we're going to go -1 to 14 also with a step to 1. And I don't like these minor grid lines, so I'll get rid of those. Okay, now if I make this go away, that kind of looks more like this graph right here. And so where is this crossing? It's crossing at approximately 1.585. Now, the reason I did this approximation one here is because while we can use graphs to solve our equations, and you can solve any equation, not just exponential, but logs, you could do linear, you could do quadratics, you can do all of them like this, where you set y equals to one side, y equals to the other side, find the intersection. The limitation though is if this wants the exact, you can see it does not give me the exact here. It does not say log base 2 of 3. It gives me the decimal approximation. Okay, so if I, to kind of show you some examples of this, for example, on page 203, part E, we went through this and we solved this and we got x equals 18. This is example 1, I believe. Example 1, part E. I think anyway. Okay, let's go with that. Example 1, part E. So what I do is I type in y equals the left side. So that's this right here. And y equals the right side. So y equals 2 and find the intersection. Now this one we already solved. So we know it goes to 18, which goes past here. So if I go, you can see right here, we get that solution of x equals 18. So this one, we can kind of shorthand. I need to know how to do it by hand, specifically on the test. But you can get to that answer by graphing these. Again, that limitation though, is what happens when this doesn't come out to a whole number, right? So if I'm solving this, which is almost the exact same one we just did, I have y equals 2 to the x, and then I have y equals 10. I go back home here. It does not give me log base 2 of 10, which that's what I want, right? I want the exact form, which means no rounding. It does give me this 3.32. So with this one, all I could really do was use graphing to verify that this is the right answer, but I cannot get log base 2 of 10 in DESMOS. Okay. Another example of that on page 205, this should be example 2, letter E this time. This is my answer right here. So if I do y equals 3 to the 1 plus or 1 minus 2x, remember, put multiple things in the exponent, you need parentheses there. And then y equals 4 to the x. Here's where they graph, but this is what my answer is, and this is what my answer is going to ask for. So we would then have to check window or alpha window number 5 and put this into our calculator. So let's actually do alpha y equals for my n over d. We have 1 over, now alpha window number 5, log base 3 of 4 plus 2, and we get this answer, this 0.36 and some change, which is my answer that I get right here. So this one, I can't solve this one just using DESMOS. All I can do is verify that that is the correct answer. So anyways, all of that to show you how to solve equations using a graphing utility. And this again works for any type of equations. You're just doing y equals the right side, y equals the left side, find the intersection.